So I'm going to talk a little bit about standards, and then I think we'll be at the past the, into the break if you're looking for more coffee. So there are a number of standards out there for how to do updates. The ITF has a working group called SUIT, Software Update for Internet of Things. The original proposal was going to be Firmware Update for Devices, which would have been FUD, and no one thought that was a great name. Um, and This working group has been around for about 2.5 years at this point. It's led by an ARM uh, guru who Canadian who lives in Cambridge and has done most of the work. And At this point, there are three documents as an information model and architecture and some strong details as to the how the bits and the wires go. And I expect them to be published as an RFC at the end of the year. They are essentially have been stable for 6 or 7 months. There's been interop tests, and it supports pretty much everything you can imagine, including, if you like, it could be applied to smartphones and desktop computers. Although in most cases, those ecosystems already have workable proprietary vertical solutions. But the hope with having a standard is that it'll be easier to have libraries and management systems that deal with all of this. And few companies actually make their their claim to uniqueness is not based upon how they do software updates. So there's a strong value in having a commonality across many things. There is a concern that a revolution in quantum computing could render the software update mechanisms vulnerable and obsolete. Specifically, the problem is that you can't, of course, update to the quantum safe signature system if you depend on a quantum vulnerable signature system for the update. And it's that software that has to do the update. So one of the things it includes is called hash-based signatures. They are believed to be quantum safe, and there's a large encouragement that this will be included in by default and just not used until we need it. So it doesn't actually define what the contents of your update is. That's actually up to you. It's really about the metadata and how you reason about the different updates. And for instance, maybe, as I said, you have to go from 1 to 1B to 2, but not directly from 1 to 2. And that's kind of included in there. And it actually doesn't say how to do the transfer either, because in most devices, there's so much variety among different devices and what kind of connectivity they have, that and across different sectors, industrial, consumer, smart city, that we can't really define an easily defined standard across all of them. But there is a lot of excitement to do that in the later on for specific areas. So if you are interested in that, that's something you can certainly be involved with. Um, and it's an open spec for read for anybody and comment, and your comments are still valuable, and we'd still love feedback from you. There are other standards out there from a number of sectors. One of them is the open OMA lightweight machine to machine spec. Um, and it involved for doing firmware updates in the days prior to start smartphones, when we all had, the ubiquitous Nokia and other phones. And it was based upon update and configuration. It really was about how do I configure these devices to be on the right networks and do the right things. And it's really taken off particularly in smart city systems where a SIM card is already involved. In which case there's not just the firmware, but in fact, you have some sensor out there, and you actually need to say, well, are you supposed to be a water sensor or a temperature sensor, and who you're supposed to report to, and other things like that. So that's out there, but it doesn't really apply a lot in the consumer space at this point, particularly because most of the consumer handheld devices don't have SIM cards except for phones, and the smartphone space has evolved into a different kind of update space. There's a lot of other legacy formats for software updates, including the fact that we have executable formats that go back, in some cases, several decades. Until hex records is from the 1970s, for instance, and it's still used by many environments as actually a fairly useful way to do an update. doesn't support signatures and it doesn't support a lot of stuff, but it may be what you wrap up when you're with your suit standard. Um, the Linux kernel has an image format called flattened image trees, which we'll talk a little bit later. Obviously, there's zip files and tar files. You may be aware that, for instance, Android APK files are actually just zip files with a signature inside of them. And we have many other formats: deb, rpm, windows update, rar files. And I don't know what the Apple iPhone physical format is, or even if it's public, I assume it is. So we're going to go through a couple of some prior art to give you some details of how some of these systems have been applied and what kind of models are out there which you may want to emulate or which you may want to avoid. And later on, we'll talk about some of the details. So one ubiquitous system is the Android system. And I know it quite well. I was involved at one point in doing a system bring up a decade ago. Um, Almost got the first video phone, but that phone failed to launch. Um, but the important part about an Android system is that it is essentially a single buffered system. You get only one copy of the system image. And in except in cases where um, you've really screwed up the system, most of the updates are over the air updates, which then involve a reboot at some point. If that doesn't work, or if there's something more complicated that needs to be done, then you reboot into what's called a recovery image, and that's usually included as a small, fully functional Android system. It can do networking, it can do LTE, it can get on the Wi-Fi, um, and it can, if necessary, completely replace the white boxes when it reboots. And usually there's some kind of process. You hold down some buttons, you hook up some cables, and if you go get if your phone is really screwed up, you go into the store, they hook up a cable, they put it into either some mode, some recovery mode, or even a fast boot mode. The fast boot mode means the orange part can replace the red part and everything else. And if you have experience rooting a phone or installing your own ROMs, then you've probably gone through that process. And it's pretty reliable because you almost never replace the orange part, and you only rarely replace the red part. And hopefully you never have to do the other parts either in regular use. So also there's a Android verified boot, where in fact the orange part measures the red and white parts, and if they look good, then it reports it to some other attestation system, and much of the banking and video apps depend upon that system to work properly in order to basically deal with digital rights management. So some cases the recovery can involve you put an SD card into the phone, and that for 5 or 6 years was the main way of doing a major system update. So you put the update on the SD card from some other system, and then you reboot into the recovery and you replace the green part. Um, Phones, the SD cards disappeared from phones, and so they came up with a way of basically doing that over the USB cable. This was not considered something end users would do typically, but rather would be done in the stores. This has become perhaps very usefully not done very often in the last 5 years, because the system on the over the air updates become much more reliable. But it still exists, and you can still do it, and it's actually a really good model for a lot of IoT systems to look into. And at one point, Google had an Android-based IoT system, and maybe your system is based on that. They have kind of abandoned that in the way that Google likes to start things and abandon them. So as I said, Android IoT platform died last year. So now that Android is a Linux based system, and there are lots of IoT systems that are based on small Linux systems. We'll come back to some of them later. Many systems are much smaller than that, and there is a bootloader called MCU Boot. And Linero is a company that will provide consulting to that, but it's an open source project that anyone can use. And MCU Boot has recently gone from its proprietary manifest format to supporting the IETF suit manifest format. And essentially, it supports as many slots as you like, 1 through N. So could be one, it could be or number zero, that is through n. It could be one, could be two, could be 20 of different images on the system. And you can boot all sorts of operating systems, Zephyr, Minute, Riot, Contiki, all sorts of RTOSes that are out there. And it's designed to work in the smallest MCUs, ones that cost $1 or so each, and are in lots of devices. MCU Boot as typically comes with your SDK, with your silicon vendor, and they will usually support you in some way if they have that. There's other alternatives to it. Um, Often MCU Boot will actually copy the images. So whatever's in primary slot 0 um, will essentially be the one that's run. And if you want to run slot 4, it actually moves the data around in the flash. That's sometimes the right answer and sometimes it's the wrong answer, but it does avoid essentially what's called needing position independent code, just sometimes bigger. Uh, then we go a little bit bigger. There is UBoot. UBoot is pretty much everywhere. Any kind of embedded system on chip that is designed to run, whether it's VxWorks or Linux or something else above it, has UBoot there. And it's been around for 20 years. It will now do verified boot of various kinds, and is typically found on a lot of devices, which without even seeing it, it boots through very quickly. And almost every system on a chip vendor has their own version of UBoot that does exactly what they want. And one thing you should be aware of is there are bugs in UBoot, and the system on chip vendors don't always ship you the latest UBoot. It's often 5 to 7 years old, and you may need to push them to upgrade to the latest one so that you can have better security options in your firmware, and to avoid you really don't want to ever ship with security issues in your bootloader, because it's the hardest part to replace and may actually require that you hook up wires to replace. But the whole point of it is that it lets you be able to replace the rest of your firmware relatively easy. One of the things UBoot does do is, for instance, it can support multiple images. And in particular, what it can do is it can boot an image once. And if that image fails to run, doesn't work right, then you can have a watchdog timer that basically reboots the system. And then it says, oh, I guess that didn't work. I'll go back to the one that worked. So you can recover back to the version that was working without a lot of hassle. That's pretty important for out there for dealing with problems. It doesn't really usually have much networking, although it can do it. It's usually used for development purposes only, but it can be used for recovery, and that's often the case if you have ever recovered the firmware in a home router. It's usually UBoot has been doing that. So I'll give you an example of UBoot in production. The Czech TLD, known as CZ-NIC, they built a secure home router. It's called the Turris. The picture there you see is the MOX. The picture at the bottom is one of the older ones. It's the MOX is kind of cute in that it is, first of all, honeycombed, and it's kind of a bit like Lego, where you can add and subtract options as you like. And the way that it works is they have a 4 megabyte NOR flash, and it contains the UBoot, and it contains a recovery image, just like an Android, actually, that can completely reflash the system. But the system itself lives on an SD card, which is actually behind the plastic next to that USB connector. Actually, you can ship the system out blank with an empty SD card, and it can actually flash itself over the internet using the recovery image. But all of the UBoot and that stuff is in that 4 megabyte NOR, but it doesn't really use it on a regular basis. It runs from the SD card. And what's also kind of interesting is that it uses a flash-friendly file system called BetterFS, which is inspired from the Git revision control system. And that system allows you to have multiple versions of the same operating system. And so you can actually roll forward and backwards as many times as you like. And that includes both operating system changes and configuration changes. So one of the options, for instance, is you can reset by pushing a button on the thing, and you can reset to the last known working configuration. So if someone screws up their options somehow and they're going, oh, what do I do now? I've broken my network. Well, the answer is just go back to the last version that worked. And those get tagged regularly, and it's kind of a useful system. And if you really care and want to do, you can hold the button down and push it in various ways, and then you can have it, install from a USB key or other things like this. And it works relatively well, and it's really quite stable out there, but it is kind of designed for a home router kind of environment, not necessarily a refrigerator. But it's a good model to think about it for certain cases.